project is going to look something like this. It's kind of fun. We call it Flashlights Alive because it is a flashlight and it really looks alive, doesn't it? So this is going to be fun. We'll get started right now. The lights you see inside of the white cylinder are done with what we call pixels. These are LEDs that are smart. They're actually a red, a green, and a blue LED inside of each little white square, as well as some smart electronics on a very small integrated circuit. We're going to use these pixels to create our lights inside of our tube. They come in strips like you see in front of you. Those strips sometimes have a sticky back, sometimes they're just smooth. These happen to have a sticky back, and what we're going to do is we're going to wrap them around something like this to get a shape that ends up looking like this. And that will go inside of the tube. You could use any number of pixels you want for a project like this, but so that it fits nicely into our cylinder here, we've decided to use 24 pixels. We've got 3 extra pixels that we're not going to use. So we just snip it right along the little fine line, and we can then connect the pixels that we need right here, making sure that the arrow, the little tiny arrow on these, points the same direction. That's very important. To verify that our soldering was done correctly, we can use the multimeter. We're going to put this on the setting for ohms, and when it's on this particular setting, if we touch the 2 leads together, which would be like having no resistance at all, we get a beep. So what we want to hear is that beep when we go from ground on way down at this end to ground on this end. That means we have a good connection all the way through. Let's do this for the +5 as well. Yep, got a good connection. Now we can't do that for the data because the data connection isn't made directly through. It goes into a little integrated circuit inside of each of these and then comes out on the other side. So we can't really measure the continuity or the connection all the way through those. Our next step will be to wrap this strip of pixels around this 5/8 inch piece of dowel. Now, since it's probably not going to stay very well, we're going to use a piece of tape to hold it in place until we've wrapped them all down properly, right? And then as we wrap them, we're going to make sure that we have just about a 1/16 of an inch between the turns of the spiral. And we're going to wrap all 24 pixels. Another piece of tape now to hold this end. And then we're going to make solder connections again to hold this in place. I'm going to tin this GND or ground pad, which is right near the end. And that will be my first solder connection with my wire. And then we're going to use this little trick of cutting loose a little bit of this insulation, not cutting all the way through the wire, so that I can slide the insulation down, and this will insulate this wire from touching these other two connections, which are +5 and data. Then I can tin the next pad, tin the wire, and make a good solder connection right there. Now remember, this is really just to keep the spiral of our strip of pixels. So we'll just do the same thing all the way down. Just reorganizing the tape a little bit here so I can get this last pad. And we won't need the rest of this wire because this is not really an electrical connection we're making. This is actually just to hold our pixels in a spiral. Now let's see what happens when we take the tape off. There we go. All ready to put inside our cylinder. If your spiral had some rough treatment getting it off, you might want to check the continuity again. Make sure that we haven't messed up anything. Here we go. So again, we measure from ground to ground. Well, we're ready for our next step. We're now going to put together the three critical electronic components to make our flashlight alive come alive. So this is an ATtiny88. It's very much like the Arduino Nano, but it has a little bit different characteristics, a bit fewer components attached to the circuit board, and it takes a different way of loading the program. That's okay. The advantage to it is that they can be purchased for between $1.50 and $2 a piece. Very inexpensive and very smart. We are going to use this 3.7 volt LiPo battery. The battery will take a charge, but then of course it will run down. So we need a way to recharge it. That's this little guy right here. This is a charging circuit. It plugs in via this connector, which is a micro USB, pretty standard. The other end would have a regular USB on it that you could plug into any standard wall adapter or sometimes in wall outlets these days. For this to all work, we're actually going to put these three components together. We're going to glue the charger to the battery and the processor to the battery. That makes a neat little package. Let's do that. I like to put the charger on this side of the battery at the same end that the wires come out. Okay, got our charger attached. And we've got our processor. Notice we align them with the top of the battery, and by doing that, we get a very nice little package. Now the next step is going to be starting the wiring. First, by clipping off this standard connector. That connector's used when we're going to charge this battery using a charger. we're going to charge directly from this device, and so we won't need to be able to plug in using this connector. Now, this battery is live. It has a charge in it. And if we were to just cut right through those wires like that, we would short out the battery for as long as our pliers are cutting through those wires. We cut them one at a time so that we don't have that problem putting a very heavy drain on that battery very quickly. That could be damaging to it. And there we go. The ground lead needs to go over here to where it says minus. It says out minus. The other end says out plus. So that means that this wire is going to go to here, and this wire needs to go over to here. This one's going to be a little short. This one's probably long enough. But this also then has to power the processor. And it's going to power it via this ground connection right here, and right next to it, 5V. That's 5 volts. Our next step is going to be beginning the wiring that will connect the battery to the charger to both a power switch and a microcontroller, and need to hook up our pixels. So let's get started. There are 4 connections on the battery charger. 2 of them are to connect up the battery. The other 2, out minus and out plus, power the microprocessor, the lights. We're going to have an extra LED that's our flashlight. So let's see how this goes. Now, our battery is live, so we need to be careful that we don't let the plus and minus connections short to each other, get the battery very hot very quick, and that would not be a good thing. So, battery minus will be the black lead. Battery plus will be the red lead. If we have connected those properly, then we should be able to measure the battery voltage, now protected by the protection circuitry on here, on the output connections. So we'll put our voltmeter here and measure the output. Black on minus, red on plus. There we go, 3.7 volts. We're going to be powering our lights and our microcontroller, but it's going to go through a little switch so that we can turn it on and off. This is what's called a single pole double throw switch. To hook this up, we're going to tin our wire, and we're going to use a red lead to go both to the switch and back from the switch, indicating that this is our power lead. This red color always indicates that that is the lead that's carrying the power. So we'll tin this guy and this guy. We don't need very much of a connection here, so we'll trim that right down to almost nothing. We'll leave enough wire so that when we connect this guy up, we'll have a little bit of extra to work with when we put it all inside of the container. Now we trim this up a little bit. For now, we're just connecting the output of the charger, which is being fed by the battery at the moment. This is going to need to come down and do kind of a dual connection. We're connecting it to the 5 volts on our processor. Let's see if we can connect that up. Okay, made our connections. We're going to be powering our spiral of pixels and an LED. The LED is going to be connected to the positive voltage through a resistor, one of these nice little 180 ohm resistors to make that connection. So the positive is going to connect to the resistor, and the positive in, or the anode we would call it, back quite short. And tin it, of course, like we always do, and solder those two together. Signal lead, we're going to use this green lead right here. That's the short lead on an LED. So this will be the end. This will be the point at which we're going to also fix our LED so that it will shine out the end. So what we're going to do is connect the positive to our resistor, tin the end of the resistor. Always makes a better connection when we do that. Solder that right on there. And then the green lead this point right here again, where the arrow points, is our input point. So we're going to have to hook up positive power. That'll come directly from the switch, and the black wire, the ground. The green wire, which is going to light our LED, is going to go to pin 5. And they're numbered here, 5. And pin 6 is going to light the pixels. We're going to use blue for the data to the pixels. Let's see. Yeah, there we go. Nice. We want this up as close as we can get to our processor. So these are going to be really short connections. I haven't said anything about this, but we would be doing all of this for sure with the power switch in the off position, because we don't want power going to anything right now. We might short something or ruin some circuit. So tinning the black lead, tinning the red lead. This is going to go to pin 6. Trim that. Pin 6, 10 pin 5, that's where our flashlight light is going. We will be ready to try this out, but we haven't programmed the processor yet. So that'll be the next step. The first 3 lines are things that have to do with setting up the NeoPixels so that we can talk to them using a library created by Adafruit and defining which pin we want to talk to them through. That's pin 6 in this case. And then a standard setup, which is here NeoPixel strip, and we're setting up 24 pixels, which pin it's on, that was set up right here, pin 6. The order, whether it's going to be red, green, blue, or blue, red, green, and so forth, that's done here. And one more setup feature for the speed. In the setup function, we have also added this one line, pin mode, and we've got pin 5 in here, and we're setting it for output. Now, this is the line that tells which pin to use for the flashlight LED. And then these other 3 are also setup things that only get run once. This is to start the strip, setting the brightness, and then telling it to begin showing. Now, Loop has quite a few different lines. Well, each of these will send us through a different display. The first 3 are just basically colors. Then we have these theater chaser ones that use white, red, and blue. And then a rainbow feature, and a rainbow feature that cycles through the colors. And then finally a theater chaser that uses rainbow. These 3 are set up with a way to say how long they will run. The first one's set for 20 seconds. The cycle one is set for 20 seconds. And the third one is set for 50 seconds. As we scroll down, we see that there are several functions that are called from the lines in the loop. First we see the color wipe, then the theater chase, then the rainbow, rainbow cycle, and theater chase rainbow. Color wipe, rainbow, rainbow cycle, theater chase with the rainbow, and finally wheel, which is used by several of the other functions we've just looked at. Now, rather than going into a lot of detail about how these functions work, let's just be aware that if we were to comment out certain of these functions simply by using the 2 forward slashes to make each of these lines a comment, we could comment out literally everything except what we want. Let's suppose we only wanted to see theater chase. And we still have digital write, that's for our flashlight LED. Now we're going to do something we haven't done before. we're first going to compile this code. This verifies that the code makes sense, that it doesn't break any of the syntax rules. And what we see right here is that it was successfully compiled. Now we're going to compile and upload. We're now done uploading, and if we were looking at our pixels, we would see that right now only the Theater Chase strip will be working. If we now put back all of the code that we commented out a couple of minutes ago, let's then load this into our Flashlights Alive and see what we get. Send that code over. Uploading, done uploading. We basically got a finished product here. It's not packaged, but let's see if it works. If we flip the switch, and then, we see the light blinking on the processor. It's thinking, and there it goes. Wow. That's pretty exciting. Now we need to create our container. This is a 6-inch piece of PEX, a 1-inch diameter piece of PEX. For this to fit properly with our electronics, we have to cut some slots into this piece so that the processor, the battery, and all will slide in, the pixels will slide in, the LED will be sitting right here for our flashlight. The slot we're going to cut is 2 inches long, and it's about 3/8 of an inch wide, and it'll have to be cut through on both sides. But if we use the bandsaw, we can actually do both sides at the same time. Looks pretty good. Using the scroll saw, this little bit at the end here. Well, now let's see if we can put the whole thing together. We've got our container, we've got our electronics, our lights, and we'll see if we can make this all fit inside of here. It's a tight fit, and it takes a little fiddling, but I think we can get it to go in. Whoa, we got it. There's our LED for the flashlight. Let's see what happens. Does it still work? Ooh, I see lights flashing. Look at that. Let's go to cad.onshape.com. We go to public. We can go find Flashlights Alive. Whoa, there's our components. This is our Flashlight Alive switch insert. This little guy is shaped in such a way we can put the switch through and then turn it so it goes this way. And we could also look at the cylinder. Looks pretty much like what we created. Nose piece at the flashlight. goes through. That's just the right size for that LED, and it is an insert so that it's not bigger than the actual PEX tube itself. This piece is the place where the switch goes through. So the insert allows the switch to slip through it and turn. This then covers up that whole end and just lets the very end of the switch through. If you want, you can create this piece. This allows you to put a lens in, and that lens then will focus the light from the LED so that it works really a lot more like a flashlight. So those pieces, you're all set to go. They can be modified any way you want because these designs are all up here on public, available to download and modify. Now that we have our Flashlights Alive working, we just need to put together the 3D printed parts that we've made. Here's the piece that covers the little LED. Goes in like that. There's our LED sticking out. This one's a little trickier. We put in the, goes in, and we give it a little bit of a turn. There we go. Now we've got our piece with the hole ready for the switch. We're gonna line that up, slide that on. There we go. Our piece that's got our lens in it. Let's see what happens when we apply the power. There it goes, even the flashlight. Well, hope you've enjoyed this. I hope you have fun